Hello, in this video I'm going to give a brief biographical background to Sir Isaac Newton. I mean, this is the guy who is the focal point of our study of classical mechanics, so it's a good idea to get a little bit of a clearer picture of the man behind Newton's laws of motion. Now, Newton was born in England in 1642, famously on Christmas Day, although that depends upon which calendar you use. Back then in the 17th century, Great Britain was still using the Julian calendar, the one that was set up by Julius Caesar in 45 BC. Um, and this had been used, throughout Europe and other parts of the world for over 1600 years until there was the switch to the Gregorian calendar. This was when Pope Gregory XIII made a change to the calendar. This is the one we use nowadays. He just shortened the year a little bit, mainly because Easter was drifting away from the spring. Easter is, arguably the most important of the Christian festivals, and they wanted it in the spring, but it was just drifting away using the Julian calendar. So the Gregorian calendar shortens the year a little bit, brings in leap years, and that helps keep Easter in springtime. So this is a Catholic thing. The Pope has brought this in. So the Catholic countries picked up the Gregorian calendar first. Britain in the 17th century and for much of the 16th century, not Catholic, and didn't switch to the Gregorian calendar until after Newton had died. So when he was born in England in 1642, they were still using the Julian calendar, and he was born on Christmas Day. Now, he started his academic career 1661 in Trinity College, Cambridge, and his uncle had already been a student at Trinity College. So this is no ordinary family if you've got someone who's been off to Cambridge at that time in history. So they were relatively well to do, and he would have studied Aristotle there because Aristotle still had considerable influence. He had been the cornerstone of science for 1500 years. So although the scientific revolution had begun and people were moving to a more empirical method of inquiry, he still had to study Aristotle. Now, having said that, he also would have been studying Galileo and even Descartes, even though Descartes wasn't that much earlier than Newton. But he would have been studying all of those major thinkers. Now, that was 1661 where he started there. Now, of course, the middle of the 1660s in Europe, and including Britain, there was the plague. And a lot of people were forced into isolation for a number of years. Newton was no exception. And during these plague years, this is when he independently developed theories on calculus, optics, gravitation, and getting onto the calculus thing, of course, there's always, well, who came up with calculus? Was it Newton or was it Leibniz? Well, pretty much both of them. I think they were working independently. There doesn't seem to be any knockdown evidence that one was influenced by the other. It seems as though Newton may have discovered a geometric form of calculus earlier than Leibniz, but his description of infinitesimals and such like is very different to what we think of as calculus nowadays. I mean, modern calculus looks more closely aligned with Leibniz than it does with Newton, but they're essentially doing the same thing. So I think they both got the credit for that. His work on optics, it's a mixed bag when you look back on it now. I mean, obviously it was groundbreaking at the time, and he didn't know the things that we know now. He's very much looking at a particle theory of light. Corpuscles is what they were called. And he proposed this idea of the ether as the substance that light was traveling through. And this idea of the ether, which obviously we know isn't true now, but this held sway for a long while, even in the 19th century, when a more robust theory of light was being put together. It wasn't until we got to like the Michelson-Morley experiments when well, we started moving into relativity then. I mean, this is something which is relatively recent, that that switch from part of the transition from classical to modern physics. So that idea hung around for quite a long time. He also did a lot of work as part of his optics on telescopes. He developed the first reflecting telescope, the Newtonian telescope. So this is where you've got light coming in the aperture of the telescope. You've got a primary mirror at the bottom, which reflects the light up to a secondary mirror, and then out to the eyepiece near the aperture of the telescope. So that's the Newtonian design for reflecting telescope. So he came up with that as well. So this was a productive time during the plague years in the 1660s for Newton and his work. But of course, we shouldn't forget back then that Newton, like many of the scientists, they were also interested in things like alchemy and other types of magic. I mean, a lot of crazy stuff as we'd think of it nowadays. The renowned scientists of the time were really into these sort of things, and Newton was no different. I mean, part of his acceptance of gravity as something that could act at a distance, that you could have these two, the Earth and the Sun not in contact, but still having that force of gravity there. His acceptance of that action at a distance quite possibly owes a lot to his interest in alchemy and these sort of magical ideas. So he returned to looking at these celestial mechanics in the late 1670s. This is when he was looking at Kepler's laws and the data that have been collected around that. And that is when he started pulling together his Principia Mathematica, his sort of master work that was published in 1687. And it really is incredible to look at. I mean, a lot of people nowadays sort of poo-poo either in a tongue-in-cheek way or in an ignorant way. They poo-poo the work of Newton and how, oh yeah, it's just obvious and all the rest of it. But I would suggest looking at the Principia. It is no walk in the park to go through it. It's an amazing piece of work. And it's something that the majority of people, even high quality educated scientists, are still going to need a commentary in order to help them to understand it. So it's an astonishing piece of work and completely revolutionary at the time. I suppose one other thing that's worth mentioning, of course, is the apple incident. It's got this sort of mythic status now of when he supposedly saw an apple falling from the tree, and that was when he understood his law of gravity there. Yeah, it probably didn't happen. But it did, I suppose it does illustrate a couple of points that were revolutionary and new about gravity back then, that you had this action at a distance. So what is mediating the force if there is no contact between the Earth and the apple? Yeah, how is this force coming about if they're not touching each other? So you've got that action at a distance. And then you've also got what the origin of the force is, because the apple is falling straight downwards. It's not going upwards or sideways or whatever. It's pointing to the fact that the origin of the force must be the Earth. So you've got those two things bound up in that story there of the apple, as mythical as it may be. In his later life, Newton, he became Master of the Royal Mint. So that's often forgotten. He was also president of the Royal Society, or the full title, the Royal Society for Improving Natural Knowledge. He was the first scientist buried at Westminster Abbey, and he was a non-conformist Christian. And this might be something where the plague again helped him in a strange way, because there was a reluctance to have non-conformist religious people in places like Cambridge University and Oxford University back at that time. And Newton was not a fan of the Trinity, so that would not have gone down well at Cambridge. So the disruption around the plague and things at that time may well have made it easier for him to continue his Cambridge career and his association with the university. But yeah, very interesting chap. I mean, he's got, he covered all of the main areas of science and mathematics back then, with astonishing innovation. So yeah, just one of the absolute legends of science.